Next is Geoff Bunza, who is going to talk about automation sequencing and Arduinos.
Okay, do you have my screen? Can you hear me?
Yes, sir.
We can hear you.
Okay. When last we left off in our last episode, we were talking about the whole issue of sequencing, and we're still only focused pretty much on lighting. But the whole issue of sequencing is a really interesting topic because it's sequencing that changes the game from modeling to animation. And of course, my whole bit is going after animation. An Arduino, as we talked about last time, is this module or board, and it's got, in the basic sense, for something called an Arduino Uno, it's got 20 switches on it. And the 20 switches, as the picture shows, will allow you to switch a particular pin, one of these socketed pins over here and at the bottom, either to 5 volts or to ground. And that's what they do. What most people don't realize when they say, I'm working with an Arduino, well, there's about 24 of them in different variations. And they all do the same thing in the sense of you can sequence them, you can write what is called a sketch or a program, and they will run and work on all of these. And that is significant because the standard one that I'm using in the presentation today has 20 pins. There's a smaller one called a Pro Mini, which I use probably more than anything else, and it's got 18 pins available. But if you buy them in quantity, you can get them for less than $2 a throw. And being the cheap guy that I am, I want to go after the cheapest thing I could find. An Arduino Nano has 20 pins, but it's got this really interesting thing over here. It's got a connector that will connect directly to a don't need anything off the board. The Uno also has a USB interface on it, and it goes to this big hunky thing over here. The guy that's kind of the big guy of the family is the Mega 2560. It's got 70 pins available, 70 switches. There are tiny ones, physically tiny. I like to use them and put them inside models in funny ways. There's a DigiSpark Pro, which is kind of a middling guy. He's got 11 pins, kind of small and relatively cheap, just a couple of bucks. And then if you want to go in the other direction, the newest guy on the block is the Arduino Teensy 4.1, and it's only 37.5 times faster than the Uno or any of these other guys. So it's damn fast. The other interesting thing is that it's got an Ethernet interface built in to the little module. It also has an SD micro card interface built in on the module as well. So it's got a lot of capability in a very small package compared to all the others. All of these can run all of the demo programs that I'm going to show you today, and a lot more than that. So I want you to understand that you've got a whole bunch available, and they all have their trade-offs for speed, size, power, all of that. And in powering the Arduinos, most of them can be powered either directly with 5 volts or directly with 5 to 12 volts or from the USB connector itself. Some of them also have a separate connector where you can put the 5 to 12 volts in, and it's got a little chip on it that regulates it down to 5 volts. You have to be a little bit careful because some of the newer ones are now operating at 3 volts, not 5 volts. And that changes the resistor values that you're going to use if you connect LEDs to these switches. The basic connection that you need is some kind of USB cable. Each one of the varieties that I show you uses potentially a different kind of USB cable. So you have to know which one goes with which board. This standard old line cable is what goes with the Uno over here. Now, a lot of what I'm going to talk about, you're going to get blown by you really fast. So one of the things I wanted you to know about is this link over here on the bottom, which is Getting Started with Arduino. and it'll give you a step-by-step, picture-by-picture way to go and bring all the stuff up that I'm going to talk about. You get the software free by going to this site over here, arduino.cc en software, en for English. It comes in lots of languages. The software is free. It will run on a Windows machine, on an Apple machine, and on a Linux machine. So depending on your flavor of the month, you can handle them all. To set up the tools, it's pretty straightforward. You download the software. Again, it's free. Put it on your machine. The one you want to go after is if you have a Windows machine, is the one that says windows.exe. 1.18.13 was the latest version as of this date. But you can also download the examples that I'm going to show you today from this website here. And that's my website. But if you go to Clinics, you'll find NT5, very cleverly named for the 5th new, what is this? New Trains presentation. That zip file will contain a bunch of different sketches or scenarios or sequences that I'm going to show you today. And it's important that you understand that this is only the tip of the iceberg. You plug in your cable, plug it into your computer, and start running the Arduino editor, which you downloaded up here, this windows.exe Arduino 1.18.13, and away you go. This is what'll come up on your screen. This is the basic editor. And what I usually tell people to do is to know how to go do the most basic thing. And the first thing you need to do is to tell it which one of those little boards you're going to use. So you go to Tools, Board, and you select the Uno. That's it. Very difficult. Then you go and you say, okay, which USB COM port are you connected to? And it'll list the COM ports. And usually if you're using an Uno, it'll come up and say the COM port and then Arduino Genuino Uno. And that, you know, is the right COM port, especially if you're just starting it for the first time. What I ask people to do next is go to the examples under File. So you go File, Examples, O1 Basics, and then you find this little thing called Blink. You click on that, and this is what comes up. Guess what it does? It blinks a light on the board. That's all that it does. Now, why is that important? Because sometimes you mess things up. Sometimes, if you're like me, you destroy the boards in experimenting. So what you do to have this blink around is you basically are verifying everything you've got loaded and working and connected is actually going to work. You then click on the right arrow, which is over here and pointed to by my red arrow, and that will start a little loading bar going down here, this green thing here. And at the end, if everything goes well and no errors are indicated, you have two white text lines and nothing else. No colored error lines or anything else like that. And that's how you know you got it through all the way. And if you did that, what happens is the little light on the Arduino is going to start blinking almost immediately. What I then tell people usually to try to do the first time that they go through is look at that program that was loaded, which is right here. It's right here. Now, this is a text editor. I'm not an advocate of teaching modelers how to program. That's a disaster in waiting. However, if you can write an email and edit it, you can go here and you can edit that text to do the following. You can go and change this number here, this 1,000, to something like 80, and change this 1,000 to something like 80, and rerun it by going back and clicking that little right arrow again, go through the sequence and download it. And then what should happen is that it starts blinking considerably faster. So you just would have gone through, edited the sketch, the program, and literally changed it so that it blinked a lot faster. In every example that I'm going to talk about today, you have that ability, and the things you want to change are right at the very beginning, meaning the top of all the text in the editor. And here's the projects if you download that zip that I referred to before that you've got available. You can have blinking lights, rotating beacons, crossing signals, a fire, a welder, building lights like I showed you in the very first entry of this series, a simulation of a black and white and color TV, Christmas lights, etc. All through that. And I'll show you how you get to those later. The significant thing, even though I'm going to show you a picture where there's a mock-up of a TV and loading the sketch for the TV, a bunch of these are what in animation I would label indirect lighting. They're not meant for you to build a little TV and look at the light. What they are meant to do is to put those lights in a room, maybe off to the side so you can't directly see it. And then when you run those lights and run the little sketch for color TV, it will look like from outside the window as if people inside that room were watching a color TV or a black and white TV. And I'm going to show you a little bit later what the welder indirect looks like as well. All of these are little features that you can go and load. You don't have to even use a soldering iron to put these together. You can use a solderless breadboard and simply push all the connectors from the wire leads of the LEDs or your resistors in here and then run jumper wires over to your Arduino. So you don't have to go through, and solder things, although ultimately that's really what you want to do. I mentioned before that I always recommend that you have a selection of resistors and you use those to substitute to get the right brightness that you really want. I still recommend that. Here's a set of values that when I do a clinic, we usually provide to people. It's a reasonably good set of values to use. Most of the LEDs that you're going to use, I always advocate using white ones. You don't have to, but this is a good selection. If you've got a 5-volt source powering white LEDs, you'll get a very good range from fairly bright to pretty dim. And let's see if this will go. Here's the barrier lights of that set that I showed you before. A single blinking light in sequence. Notice the switch turns it off. Every one of these has a master switch to disable the animation. Remember the building lights that went very slowly through the cycle and are completely random? Here's the simulation for that with the sketch. This is probably the single most used and interesting lighting animation you could put on a layout. It's subtle, it's in the background, and when people suddenly realize what's going on, they're quite surprised, especially if you don't tell them about it. Down in the corner here is where we have the welder simulation. Here's the pseudo black and white TV. Again, it's never meant to be put behind that, but I did it anyway. Chase lights for a marquee or a movie theater. A different pattern. Notice that the timing is different. Christmas tree. Had to have a Christmas tree. And also you can see the crossing signal down here. This would be the color TV. You could barely make out the changes in color. There's 3 different colored LEDs behind it. Campfire light. Interesting thing about this campfire, it uses a red, a yellow, and a white LED. The white is for the snap, the crackle, whatever, when there's a burst. And it's pretty effective campfire. Imagine these are rotating beacons for a buoy or something. Or maybe atop a police car, or even a locomotive. Crossing signal again. Runway lights for the more modern fellow. Strobes for police cars, emergency vehicles. And of course, you can go and change the timing on those, faster, slower, on more than off, whatever you want. Here's the welder in direct. It uses two LEDs, a blue and a white. The effect is pretty good. Completely random, goes on for a short burst and comes on again. Many people ask me, well, is that all you can do? Is that what animation's all about? Well, sequencing is what it's all about for lighting, and this demo is another sequencer. So we can watch a little TV. There's the NBC Peacock. Oh, it's the wonderful world of color. That's a scale TV, HO scale. It represents a 26-inch model that was new at the time from RCA, either in 64 or 66. I don't remember the year. Notice when you change channels, you get all the noise. Those are actual TV clips that you can grab off of YouTube and rework and put in yourself. I think we need to change channels again. There we go. Oh, not yet. You can also see at the top of the screen the room lights going on and off. The Harry's TV sign, by the way, is backlit. It's a multi-layer set of styrene, and the LEDs are actually mounted on the top facing down. So the white styrene actually diffuses all the light. I had to put in Man from U.N.C.L.E. It was one of my favorite shows. Okay, that's enough TV for a day. Let's get back to modeling. So the issue in sequencing is that you can go from very simple to very complex sequencing. All of those pictures that you thought was the TV picture was actually individual pictures being thrown on a screen by an Arduino, also controlling the lighting in the building. And it's putting a picture on a screen 40 times a second and just going through one picture after another, after another, after another that was pre-selected and stored. Kind of the ultimate long sequence. I think it's like 800 or 900 pictures that are sequenced and thrown out. Here are your part sources again. And the thing that I wanted to point you to, if you're really interested in getting into this in detail, and with a lot more explanation than I can do in 15 minutes, if you go to the very first article, A Modeler's Introduction to Arduino, with that link, you'll get blow by blow, detail by detail, how to set it up with a lot more pictures and links to everything else that you might want. And if you missed any of the links or anything else here, at the bottom of the screen, I put the presentation for today together in a PDF, and you can use that link to get to the PDF. So if you want to go back and refresh your memory on where the links were, that's where to find them. This is going to be the second to the last presentation of this group. Next time, I'm going to have a kind of a transitional presentation, still on animation, talk a little bit about moving into animating with movement and sound and keying off of what we went through with lighting here. There's a lot more to lighting, a lot more you can play with, a lot more to learn. But this gives you kind of the first flavor of all of that. So if there's any questions, I'll be happy to take them.
Geoff, right off the top, using the Uno and using your on-off switch, which pins were those connected to for the what I call the master on-off?
I think the master on-off went to A0, which on an Uno would be pin 14.
Okay.
And it's easy to find. If you look at the sketch, at the beginning of the sketch, it'll say something like master reset or something like that.
Master
And,
reset.
and,
Okay.
and next to it will be a number, and that'll be the number of the pin.
And the other one to ground?
The master always goes to ground to turn it off.
Okay.
Okay.
So with the, yeah, and probably A0, which I think is, you're right, is 14, and
Yeah.
then to ground.
Yeah.
All right. Thank you.
Yeah. And it also, if you look at the PDF, it has all that in gory detail too. So you can't forget it.
Sounds good.
Any other questions?
I
I know-
have to tell you, that was a good presentation.
Yeah,
I am using Arduinos for the signaling system on my railroad.
Oh, good for you.
Looking at all the different conditions like occupancy and switch position and producing the correct aspect on the signal. So I'm really tickled with that. So
Yeah, no, that's great. There's a lot of work that's been done. One of the things that I meant to emphasize is that every Arduino can be reloaded with different sketches, different programs.
yes.
So if you goofed the first time, you can always go and correct it and make it do the right thing. The
Thank
second, hey,
I've been
I'm
down
one of
that
the I'm one of the big beneficiaries of that. But the other thing is there are a zillion sketches being written by model railroaders out there now.
Yeah.
If you go out and you search for like Arduino model railroad signaling, you're going to come up with page after page after page of all kinds of variations of signaling systems from all over the world.
You just have to take the time to look at them and understand what you're looking at.
Right, absolutely.
I don't 100%, but thank God I've got some friends that help me. So it's good.
Clark
yeah.
has
I have a question. It may be because you're just doing an introductory thing, but why wouldn't you use Neopixels instead of like 6 different lights for different colors?
well, you could.
Yeah.
Neopixels tend to be more expensive. I tend to be a cheap son of a gun. And so I go in and look for, secondhand or surplus LEDs that tend to be very, very bright and that, I'll pay like 2 cents a piece for. And that way, when I burn them out, I don't really care.
Okay.
And that's the absolute truth. I mean, I look for really cheap stuff. I think on a former presentation, I said, I usually now only buy white LEDs and then I color them the way I want them to be colored.
Sure.
I rarely find a situation where I actually want a single LED to run multiple colors. The obvious exception would be a searchlight target signal where you want it to go red, yellow, green. And you can actually get a really interesting, very tiny LED that's what's called an 0602 surface mount device LED. It's got 3 of those LED colors in one package.
Right.
And the reason why that's really neat is you can put that in an N scale target signal and the colors are outstanding.
Right.
And they're very, very bright.
Yeah, just in buildings, I've been using the Neopixels because I can vary the different colors in the rooms. And
Absolutely.
And at different times and sequence them with the Arduino. So
Yeah,
I just find them fantastic, and really they're not that bad. I think I got 50 for, I don't know, $12 Canadian or something. So
Yep.
but all right, that's great. Thank you very much though. Good information tonight.
There's way too many options out there.
Oh
You
yeah, yeah,
could
So
spend
ju-
half your life just looking at all the options.
absolutely.
Jeff, what was the display? What was the display you used for the color TV? The display element.
Yeah, it's called an SD 133, I think it's 1332 OLED display, OLED.
Yep.
And all I do is go out on if I have a project in mind and I want a little tiny display, the first thing I do is go on eBay and I search for display and try to find out what the standard sizes are. Then I'll go out on Google and I'll look for other sources for that. But the one thing I look for first is whether or not when I Google that display, Arduino and library, a library shows up.
Right.
And the reason is I don't want to write any more code. I spent 40 years doing that. So I had enough. And I want to do modeling. I don't want to program Arduino. So the fact that I use Arduinos means there are more libraries written for Arduinos than any other little processor out there. And there are a bunch of little processors out there. But there are libraries galore, all of them open source, meaning all of them free. If you don't like it, you could go and change it. But the fact that somebody's already done the work to connect to a hardware device, to me, that's great.
I'd like to make a comment. I'd like to make a comment about the Arduino libraries. Once you install the library, if you go to the examples menu in your Arduino, many of those libraries have several examples, and that can be your kickoff point to modify the way Geoff suggests.
And that's exactly what I do. So thank you for that, Ted.
When you said you color your LEDs, what do you use to color them with?
I use Tamiya clear acrylics.
Okay.
And the reason I do is A, they're cheap, and you can mix them. And
Right,
virtually every local hobby store has them.
Right, yeah,
And you can get them on the net too.
right, yeah. That's
Jeff,
what
Jeff, I hate to cut this off, but I have to because we've got such a full show tonight. And thank you so very much for everything that you've contributed this evening, because I really think it's interesting material.
Thank you.